Okay, guys, this video is dealing with oxidation and reduction reactions. So, oxidation, reduction reactions, which in one word we call them redox reactions. So it is taking this part of the word and this part of the word, and it is calling it as redox reaction. Okay. Okay, so you may have heard that when an acid and base are reacting together, then this is characterized as a proton transfer. But when oxidation and reaction is happening, or redox reaction is happening, then during this reaction, what is happening is that the electron is known as the electron transfer reaction. So the electrons are transferred. So during this reaction, as we see even on the previous exam or on the previous video, what is happening is that the electrons are transferred from one compound or element to another compound and element. So let's suppose that we have the formation of calcium. Let's do sodium hydroxide. It's sodium chloride first, because it is easy, and then we'll move to calcium oxide. So again, if we bring part of the videos on the first part of the or the previous video, what is happening during oxidation and reduction reaction is that one element, so let's suppose that we are dealing with element A here and element B here, one element is giving the electron and the other element one way or another. We saw in the previous video that sometimes this giving away the electrons or transferring the electrons is happening spontaneously, and in some cases is happening through the force of the battery that is pulling the electrons. So when we see that is spontaneous, then on the table on page 7 of your data booklet, what it is that the one that is the one is above the other. Okay, so now during what is happening here, remember what we said, that reduction is happening as the electrons are gained, and oxidation is happening as the electrons are lost. Okay, this may sound confusing because you are saying it's gaining but it is reduced, and it is losing but it is oxidized. There are, as I mentioned even on the previous video, there are historical ways as to why this is happening, and we will touch base on some of them on this video and probably on the other videos as we move forward into the unit. But let's see some acronyms that we can use for you to remember why, or that the reduction is gaining and oxidation is losing. And there are two actually that this is why this is happening. So when we take a look at those atoms A and B here on the picture, then we see and we notice that atom A is giving the electron and atom B is receiving the electron. Okay, is gaining the electron. So this is losing the electron and atom B is gaining electrons. Always electrons. Okay, so now keeping in mind that when you are losing electrons, you are being oxidized, we can say that atom A is going through the process of oxidation. And what is happening with atom B, since it is gaining the electron that atom A is giving to, it is going through the process of reduction. In other words, what we can say is that atom A is oxidized and atom B is reduced. Just always keep in mind that reduction is gaining and oxidation is losing electrons. Now, especially if this is the first time that you are taking the course and first time that you are hearing those terms, then this may be a bit confusing for you. But how come that, like, you may say that, how come that when you gain, you reduce? When you gain, you add more. But one way to think about it is when in terms of the charges. So if you have here is 0, and then you have +1 here, +2, and +3 charges, so at those points here. And then on the other side, you have a -1, -2, and a -3. When you add electrons into a charge, when you add electrons into a charge, that you become more like your charge is becoming more negative. Okay, and when you take away electrons, electrons away, then you become more positive. And again, this may be still confusing. And then to help you to memorize this, we have 2 acronyms. One that is OIL-RIG, and the other one, if you like animals, is Leo the lion says grr. Let's take a look at those 2 so that you use whatever you prefer. So the first one, which I personally like most, is OIL-RIG. It is related to Alberta, and I like it. It's simple, it's easy, and you don't have to make noises of it. So for oil, it's oxidation is losing, electrons, so oil is losing, and for rig is reduction is gaining. I personally like this more, gaining. Okay, it's gaining. I personally like this more than Leo the lion says grr, but you can use whatever you want and whatever you prefer. So Leo the lion says grr. Okay, so what it is when you are losing electron, you are oxidized, losing electrons equal oxidized. and gaining electron equal reduced. Okay, so any of them, whatever makes you remember that losing electron is oxidation and gaining electron is reduction, you use it, one of the two. Personally, I prefer oil rig. It's simple, it's easy. We are used to here in Alberta. But if you like animals, then you can use Leo the lion says Gur, and any of them will serve the purpose. Okay, so as I said, one of them or both of them you can use to remember that when you are losing electrons of then the process or what is happening with the compound or the element is oxidation, and when you are gaining electrons is a reduction. Any of those or two of those use, it's fine. So let's work with a simple example, which in which we see the oxidation and the reactions, and the oxidation and the reduction happening. And this is in, let's say, sodium chloride. So sodium chloride is an ionic compound. We know that sodium chloride is an ionic compound since science 10. So what is happening in that, it's the table salt. What is happening into it is sodium and chlorine are reacting together to form that is known as the sodium chloride, which is an ionic compound. Now, in terms of the atoms, so what is happening, I will use different colors here so that you can see. A sodium atom is reacting with a chlorine, and what is happening during this reaction? Sodium is giving the electron to chlorine, and in this case, what is happening with chlorine is becoming negatively charged, and what is happening with sodium is becoming positively charged. And when we have two entities that are opposite charges, one of the law of general electricity is that two opposite charges will attract each other. So what is happening now is that this sodium that what is becoming positively charged will be attracted. So sodium plus will be attracting that chlorine that is negatively charged and will form together in that is known as the sodium chloride or the table salt. Okay, so if we kind of break it down into small steps, we start as a sodium atom and a chlorine atom. They are neutrals. When we say atom, then that means that they are neutrals. So what is happening in the process is that sodium is giving away the electron, and chlorine is receiving that electron that sodium is giving away. Okay, and on this case, what is happening to the sodium atom is becoming an ion, and a sodium ion, and chlorine atom is becoming now a chloride, which is an ion of chlorine, negatively charged. Therefore, since they have the opposite charges, they will attract each other, because two opposite charges will attract each other. Okay, so this is kind of a step-by-step process of sodium chloride formation. When we see it now from the perspective of what is happening in terms of the oxidation number, then we will have a reaction like this. Sodium plus chlorine will give us sodium chloride. So the oxidation number for sodium and chlorine are zero since we have atoms for them, and when they are in the compound, sodium will have an oxidation number of +1 and chlorine will have an oxidation number of -1. So sodium and chlorine, they start as neutral charges because they are atoms, and then they become respectively positively one charge and negatively one charge. So let's see now what is happening in terms of each of those compounds participating in the reaction. So when we take a look at sodium, sodium is giving the electron away. So when you are giving something, because it's giving the electron away, where is that giving going? It's going into, quote unquote, the product. So by giving the electron away, the one electron away, sodium becomes now positively 1. And when we have the chlorine, so chlorine starts as neutral. And what is happening with the chlorine is taking in within himself. So and as a result of this is becoming chlorine negative. So the reaction will be +1 electron. And then as a result of this, as the product of this interchange of the electrons, chlorine is becoming -1 charged. Okay, so this is what is happening into like step by step, or each element participating in this reaction here. Now, just let's see, or those two reactions are called as half reduction reactions. Why? Because it is only half part of the reaction that is shown here. Only half of it is shown here, and only half of it is shown here. And when we combine the two together, what we have is sodium, no charges, plus chlorine, no charges, and you have a +1 electron here, but let's see what is happening. And then in the other side, on the product side, we will have 1 sodium that is positively charged, and 1 chlorine and 1 electron. But since we have 1 electron in the reactant and 1 electron in the product, then we will have the reaction that we see it here. Okay, so in this reaction, what we see is that sodium is losing 1 electron. Okay, sodium is losing 1 electron. Based on oil rig, losing the electron means that sodium is oxidized. And chlorine, on the other hand, is grabbing that electron, is grabbing the electron that sodium is giving us, is releasing. 1 second. So sodium is grabbing the electron that sodium is releasing. And what is happening with chlorine on this case, since oil rig, okay, remember that reducing is gaining, is reduced. Okay, let's take a look at another example. Let's consider the formation of calcium oxide. So calcium oxide is an ionic compound. Calcium oxide is an ionic compound. If we write the reaction, then we will have something like this: 2 calcium solid. Now I'm using the state of matter in, as you noticed in the previous example, just so that you get the feeling of what it is and get the logic of what is standing behind that. I didn't use the state of matter. So oxygen gas, which is O2, remember why, 2CaO in solid form. So now, calcium oxide is an ionic compound, and it is formed between calcium 2 plus and oxygen 2 minus. Oxygen 2 minus ion. In this reaction, 2 calcium atoms give up or transfer the electrons. Okay, so the calcium gives up loses electron, while what is happening with the oxygen is gaining electrons. Okay, so when we write the half reactions for this formation, what we have is something like this, that 2 calcium, okay, 2 calcium are giving up 2 electrons. So if 1 calcium is giving up 2, then 2 calcium will be giving up what? 4 electrons. If 1 calcium is giving up 2, then 2 calcium will be giving up 2 electrons. And you can say that even if you use the multiplying it by 2 later on, so if you can use this, it still is fine. If you say that, okay, in my reaction, if I match it up, then I should have a 2 here, which means that everything will be multiplied by 2. So the final reaction will be 2 calcium, giving up each of them 2 electrons, creating 2 calcium ion and 4 electrons. On the other hand, what is happening with the oxygen is receiving those electrons. Okay, so if we are writing it as 1 oxygen, then we will have 1 oxygen. 1 oxygen will receive 2 electrons to form that is known as the oxide. Ion. However, when we multiply, oxygen cannot be on its own, so it is A2, and then times 2 times 2. So as the final half reaction, we will have 4 electrons here. And it does make sense because the number of electrons based on the conservation law of charges, it is not created, it is not destroyed. Whatever is given away will be grabbed or absorbed by something else. Those are known as the half reaction. Okay, and in half reaction, explicitly the number of the electrons that is either released, given away, lost, or absorbed, gained, are shown. Okay, and if we add those two together, if we add the 2 half reactions together, will give us an overall reaction. As I will write everything: 2 calcium plus oxygen plus 4 electrons will give us as a product 2 calcium 2 plus 2 oxygen 2 minus plus 4 electrons. And then since we have 4 electrons and 4 electrons on both sides, then we can say that the half reaction or the net reaction is 2 calcium plus oxygen will give us 2 calcium 2 plus 2 oxygen 2 minus. And now that we have two entities that are with opposite charges, they will combine together into calcium 2 calcium oxide. So now the final reaction will be 2 calcium plus O2 and will be this is what is happening. So as you see here, calcium, as we said here, calcium is giving the electrons from 0 is becoming 2 plus, and oxygen is receiving the electron from 0 is becoming 2 minus. Okay, so in the term oxidation reaction, the term of oxidation reaction refers to the half reaction that involves loss of electrons. Okay, and a reduction is a half reaction that evolves the gain of electrons. So when we are asked to write the oxidation, again, it refers to the loss of electrons. So if we are asked to write half reaction for oxidation, then since it is involving the loss of electrons, we will write the first one, 2 calcium this one here, okay, 2 calcium 2 plus 4 electrons. And if we are asked to write the half reduction that involves the gain of electrons, then we will write the oxygen 2 plus 4 electron gives us 2O2 minus. Okay, makes sense? So now you can say that in formation of calcium oxide, calcium is oxidized, and in other words, since calcium is oxidized, we call it a reducing agent. So it is oxidized, but it is a reducing agent. So I think it's, yeah, a reducing agent, because through oxidation, what it is making, it is becoming a way to reduce the oxygen. Okay, so this is the logic that stands behind it. Through the oxidation process, calcium is going through oxidation, it's oxidized, which is becoming a reducing agent. It's becoming it's giving the other element the opportunity to be oxidized. And when we are looking at the oxygen, this is becoming an oxidizing agent. Because through the possibility that oxygen has to receive, to gain those 4 electrons. It is giving the opportunity to calcium in this case to be oxidized. So there are a lot of terms that you have to keep in mind. When you are losing electron, you are becoming oxidized and you are becoming a reducing agent. When you are gaining electron, you are becoming reduced, or you are becoming an oxidizing agent. Because agent serves as a opportunity for the other one to happen. So let's take a look at another example when we have zinc solid and copper sulfate in an aqueous solution. This is a singular replacement reaction. So then we will have a zinc sulfate plus copper sulfate. So if we take a look at this, then the occurrence of electron transfer is more apparent in some reduction reaction than in some others. So when metallic zinc is added to a solution that contains copper 2 sulfate, zinc reduces copper 2 plus by donating 2 electrons to it, and then this process of the solution, copper 2 sulfate loses the blue color that is characteristics of presence of copper 2 plus ion. So what we see on this case is zinc plus copper 2 plus in aqueous solution, of course. Aqueous solution will be giving us zinc 2 plus in aqueous solution and copper metal. So the oxidation and the reduction half reactions are as follow. Zinc solid is becoming now, it's have taken 2, it's a giving 2 electrons. Zinc 2 plus 2 electrons, and copper is receiving those 2 electrons to become copper metal. A very similar process is happening even when copper and silver nitrate are reacting in between each other. We will see more examples like this in class, but for this lesson, what we have to keep in mind are some key points. So first of all, we need to know which one is called the oxidation or oxidized compound and what is happening with it. So during the oxidation, the compound or the element is losing electron versus the reduction is gaining electrons. You have 3 different ways to see it. The first one is, as you think of it, as you are adding more electrons and what into the compound, and then what it is happening is becoming more negative, and we are taking away electrons is becoming more positive. Or if you are using acronyms of an oil rig or Leo the Leon says GER, you can use oxidation is losing and the reduction is gaining electrons. Just so that you can see the process of oxidation and reaction, then this is it's sodium and chlorine reacting together to form sodium oxide, or calcium and oxygen are acting together. Which one is half a reaction? And when you are asked to write the half reaction oxidation, then you have to keep in mind that the oxidation will be on the product side of it, and the product is known as the reducing agent because it is giving the opportunity the reduced element to become reduced. Okay, it's the agent is endorsing the reducing, and when we have the half reaction reduction, the electrons are on the product side, and the oxygen in this case is known as the oxidizing agent because is endorsing the oxidation. We will deal more with those examples in class and in the upcoming videos as well. See you.